Let's see the product of this matrix with this vector. The first observation is that in order for this product to be defined, we need the number of columns of the matrix to be equal to the number of entries of the vector. And then the definition of the product of this matrix with this vector is just the linear combination of the columns using as weights the entries of the vector. Then in this case we get that this is 2 times 2, negative 1, 1, plus 1 times 1, 0, 3. And then we get 4, negative 2, 2, plus 1, 0, 3. And this is equal to 5, negative 2, 5. This is one definition for the product of this matrix with this vector. And the other definition is the following. It's called the row vector rule, and it goes like this. In order to get the first entry, we use the first row and the vector, and we do a product sum. What do I mean? I do 2 times 2 is 4, plus the product of these two would be 4 plus 1 is 5. That will give us the first entry of this product. To get the second entry, we use the second row and the vector, and we do a product sum. We get negative 1 times 2 is negative 2, plus 0 is just negative 2. And to get the third entry, we use the third row and the vector, and we do a product sum. We do 2 times 1 is 2, plus 3 is 5. Those are the two ways to get the product of a matrix with a vector. Remember that in general, if the matrix has dimension n times m, that means that it has n rows and m columns. Then we can multiply this matrix with a vector that has dimension m by 1. This is a column vector with m entries. And the result is going to be, when we do the product of these two, the result is going to be a vector with dimension n times 1. That means that we have n entries. One way to remember is we write A times B. We write the dimensions n times m and m times 1. In order for this product to make sense, these two numbers should be the same, and the result is what you get when you cancel these two numbers, and you get an n times 1.